Good afternoon, John. Here's the summary of the work that I accomplished starting around November 15th or November 20th and going all the way to February 1st. The next summary will be all the work I'm doing right now, which I'll provide at the end of February, as per the contract. First of all, I ordered all the components needed to build various thermocouple and RTD boards. And I ordered them from two manufacturers, JL PCB and Next PCB. And when I got those back, I assembled them. I soldered all the headers and the green terminals to them. The second thing I did was I assembled and tested two Gen 2 8-channel sensor controllers and delivered them to Predictive Monitor, David. And these were Black Widow 2 and Black Widow 3. That's the names that David gave them. You can check with David on that. Then I integrated and tested the cellular modems for the Gen 2 8-channel sensor controllers, which use the Netgear 1200 cellular modem. This was because David needed access to the cellular modem at Predictive Monitor. Then I upgraded the Python 3 firmware on the compute running on a Compute Module 4 to handle overshield sensor reports at up to 5 seconds per report. This was a request from David. He wanted to be able to provide faster real-time updates to monitor various sensors that are time critical. And I was able to get it down to around 3 seconds, but safely 5 seconds. And he can verify that. Then I remotely updated the firmware for the Gen 2 8-channel sensor controller, Black Widow 1, to include some of the newer upgrades to the software that I had made after I had delivered it. So I was able to remotely log in to the machine that David was running and update the firmware as he requested. So that Black Widow 1 machine now has the latest software running, which has a lot of fixes and things like that. Then I integrated and tested the Sequent Microsystems data acquisition board into the new 16-channel Gen 2 sensor controller, which is called Black Widow 4, so that it is now able to read up to 4 0 to 10 volt voltage sensors and up to 4 to 20 milliamp sensors in a single RS-485 port wired sensor. Next, I updated the Python 3 Gen 2 application, sensor controller application, to read and send voltage sensors and current sensors to Overshield. So now we have these sensors being reported over Overshield. This was a request that David said he needed access to these sensors using Overshield. So I modified the software to do that. Finally, let me see. I configured the Python 3 application to scale and linearize the voltage readings and the 4 to 20 milliamp current readings into real-world values. So we now have that capability of scaling the sensors. So you can scale the voltage sensors to PSI or to degrees Kelvin, whatever kind of values you need. And it's all done through a configuration file. Then I generated a bill of materials for the new Gen 2 16-channel sensor controller for David to order. And I assembled that. Right now, the only thing missing is the RS-485, which I'm working on in the next week or two. And then that'll be connected to the new machine. Finally, I found another vendor that produces PCBs, like for the thermocouples and the RTDs, and that, as well as the main sensor controller boards. Right now, we had the JL PCB, which is the old manufacturer, but I worked with a new one called Next PCB, and ordered thermocouples from them. I ordered like 100 thermocouples, so we have plenty of them now. And I've been using these. Those are the ones I'm going to be using for this. I'm using them for the 16-channel sensor controller. I've assembled the ones we need for it. That's basically it, John. Let me know if you have any questions or comments, and hopefully this will be the last time I'll do this. From now on, it'll be every month. I'll create an invoice and give you a summary right at the beginning of the month, as per the contract. Again, do whatever you can. I understand, that this is sort of a little late, but thank you anyways for giving me the opportunity to send you this information. Goodbye.